Hi, this is my reporting. Let's talk about Philippine Electrical Code. Article 4.30 Motors, motor circuits, and controllers. This article from the Philippine Electrical Code covers motors and their control systems. It includes requirements for motor branch circuits, feeder conductors, overload protection, and motor controllers. The scope clarifies that motor control center installation is covered elsewhere in Section 1.10.11e, while air conditioning equipment follows Article 4.40. As you can see, this shows the overall structure of Article 4.30 on motors and motor circuits. The list on the left is the table of contents, from general rules to grounding and tables. The diagram on the right traces the motor's power path, highlighting each protection and control element in order. Figure 4.30.1.1 Article 4.30 Contents. It explains special equipment in Article 4.30. System isolation equipment simply disconnects motors from power using remotely operated lockable switches. Valve actuator motor assemblies are factory-built units that move valves and include the motor, controllers, limit switches, and overload protection, usually for short time, high torque operation. So, kini mo na yung mga safety regulations for part winding start induction motors. It emphasizes individual protection for each winding half using overload devices with specific trip currents. Branch circuit and ground fault protection must be rated at half of what's specified in Section 4.30.4.2, with exceptions for short circuit protection using time delay fuses. From this section, 4.30.1.6 outlines how come to determine the correct ampacity and motor ratings for electrical equipment. It states that conductor sizes must be selected from ampacity tables or calculations, referencing sections 3.10.2.6b and c. For general motor applications, we use tables 4.30.14.1 through 4.30.14.4 to find ampacity, especially when horsepower isn't directly given. Article 4.30 nag-focus na siya sa mga motors, motor circuits, and controllers. Table 4.30.14.4 is used for motors with low speeds or high torques where nameplate current ratings should be used, and kaning exception to nag-highlight na siya for specific equipment like shaded pole fans. The full load current on the equipment's nameplate should be used instead of horsepower for calculations. And exception 3 states that if an appliance has both horsepower and full load current on its nameplate, use the full load current for calculations. Also, for torque motors, the rated current should be locked rotor current, which is used to determine ampacity and protection as per section 4.30.4.2b. For this slide, it covers AC adjustable voltage motors and valve actuator motor assemblies, or VAMs. For AC adjustable voltage motors, use the maximum operating current on the nameplate. If unavailable, use 150% of values from tables 4.30.14.3 and 4.30.14.4. For bumps, use the nameplate full load current. Also, motors must be marked with the manufacturer's name and rated volts per full load current. Slide continues the requirements for motors markings under Article 4.30. Motors must include rated frequency per phases, full load speed, temperature rise, and time rating. Horsepower is required if 1 per or 8 horsepower or more, with exceptions for certain motor types. Alternating current motors rated 1 or 2 horsepower or more need a code letter or locked rotor amperes. For this slide, ano mga list mga motor marking requirements. Design letters for specific motor types, secondary voltage for wound rotor motors, and field current or voltage for DC synchronous motors are needed. Motors with thermal protection must be marked thermally protected or TP, and impedance protected motors as impedance protected or ZP. So the next slide focuses on lock rotor indicating code letters on motor nameplates. These letters per table 4.30.1.7b indicate motor input with a lock rotor and must be in a designated block. Multi-speed motors are marked with a code letter for locked rotor kVA per horsepower at the highest speed. Single-speed motors use a code letter for the Y connection. Also, dual voltage motors use the code letter for the highest lock rotor kVA per horsepower. Motors with 50-60 Hz ratings are marked based on 60 Hz. Part winding motors use a code letter based on the full winding. Torque motors are marked per 4.30.1.7a using locked rotor torque instead of horsepower. Multi-motor equipment needs a visible nameplate with the manufacturer's name. And so nag-discuss din siya sa mga marking requirements for multi-motor equipment and controllers. Ang factory wired equipment needs voltage, frequency, phase, conductor ampacity, and protective device ratings. If not factory wired, individual nameplates can suffice. Controllers must be marked with the manufacturer, voltage, current, or horsepower rating, and short circuit current rating with an exception for specific applications. Exception to controller short circuit rating markings are detailed here. These are not required if marked elsewhere on the assembly. If the assembly has a rating, or for controllers under 2 HP at 300 voltage for general circuits, controllers with overload protection need markings for that protection, and combination controllers need markings for trip settings. So here, controller markings are not needed if the data is on the nameplate. Ang marka sa controller dili kinahanglan kung ang impormasyon naa sa nameplate. For integral controllers, markings on the equipment nameplate are allowed. Para sa mga controller nga apil na, pwede ang marka sa nameplate sa equipment. Terminals of motors and controllers must be marked or colored for proper connections. Use proper conductors unless specified otherwise. So, gamit og copper conductors gawas kung lain ang gi-specify. Ang control circuit devices nga screw type terminals nga nagamit og 2.0 mm squared o mas gamay nga copper conductors, kinahanglan i-torque sa minimum nga 0.8 non-metallic. 4.30.1.10 Wiring space in enclosures. A. General. Enclosures for motor controllers are disconnecting means shall not be used as junction boxes, auxiliary gutters, or raceways for conductors feeding through or tapping off to the other apparatus unless designs are employed that provide adequate space for this purpose. So, ang mga enclosure para sa motor controllers or disconnecting means dili dapat gamiton isip junction boxes o raceways gawas kung dako-dako ang lugar. Ang table 4.30.1.7b nagpakita sa mga lock, rotor indicating code, letters, o ang ilang mga kuan ang bali katumbas nga kilovolt amperes per horsepower nga naka-lock rotor. Wire bending space in enclosures. Minimum wire bending space in motor controller enclosure must follow table 4.30.1.10b. Alternate wire terminations must be manufacturer identified and not reduce bending space. Ang exposed nga current carrying parts sa motor kinahanglan protektahan sa mga liquid gawas kung ang motor gidisenyo para niadto nga kondisyon. Ang motor terminal housing kinahanglan gid kaan sa metal, pero ang non-metallic housing pwede sa mga non-hazardous nga lugar na internal grounding. Dere para sa for wire to wire connections, ang terminal housings kinahanglan makatuman sa minimum dimension o volume sa table 4.30.1.12b. Ug para sa fixed terminals, ang housing kinahanglan maghatag og minimum terminal spacings ug volume kada table 4.30.1.12c 1 ug 2. And also ang large wire factory connections na kinahanglan og ample size housings, pero ang volume provision dili siya applicable. Ang equipment grounding connections kada 2.50.1.8 kinahanglan jud sa motor terminal housing. Exception: where a motor is installed as a part of factory wired equipment that is required to be grounded and without additional connection being required at the motor terminal housing during equipment installation, a separate means for motor grounding at the motor terminal housing shall not be required. So, if a factory wired motor is grounded and needs no extra terminal housing connection, dili na kinahanglan ang bulag nga grounding sa motor. Ang brushing nagprotect sa mga wires nga moagi sa enclosure openings, ug kinahanglan kini nga soft ba ug dili madaot sa mga grasa nya. Ang mga motor kinahanglan nga naisaktong ventilation ug dali ma-access para pod sa dali nga maintenance. Exception: ventilation shall not be required for submersible types of motors. So it covers exceptions for motor ventilation and the placement of open motors with commutators to prevent sparks from igniting combustible materials. So also nag-present ni siya sa table 4.30.1.10b. It specifies that minimum wire bending space required at the terminals of enclosed motor controller based on wire size and the number of wires per terminal. This section outlines specific guidelines for motor installations. It permits motor installation on wooden supports for dusty environments. It mandates enclosed motors or specialized ventilation systems. Determining motor compliance involves referencing rated full load currents from specified tables. And also, it states that the numerical AC voltage should be used to determine the voltage in rectifier systems. So next is part 4.30.2. Nag-focus ni siya sa motor circuit conductors. And it specifies conductor capacities para ma-prevent ang overheating under specified conditions. These provisions don't apply to circuit over 1000 volts. And Article 2.50, 3.0, and 3.10 don't apply to integral conductors within equipment like motors or controllers. Use the nominal DC voltage of the rectifier if it exceeds the peak AC voltage. And also, this section details conductor requirements for single motors in continuous operation. And conductors must have an ampacity of at least 125% of the motor's full load current. For DC motors with a rectifier, the conductor capacity of the rectifier's input should adhere to specific standards, and the auxiliary leads can be neglected if they don't significantly contribute to the current carrying area. As you can see, table 4.30.1.12c 1 and 2. It details minimum terminal spacing and usable volumes for fixed terminals based on the voltage and conductor size. And it specifies conductor ampacity for DC motors from a rectified single-phase supply. For half-wave rectifier bridges, 190% of the motor's full load current rating ang imong gamiton. And for full wave bridges, 150%. So for this slide, it addresses conductor sizing for different motor types. B is multi-speed motors. Use the highest full load current from the nameplate. And for Y-start delta run motors, conductors on the line side should be 125% of the load full load current. And while those between the controller and the motor should be 72%, the requirements for part winding motors are also addressed. For part winding motors, conductors between the controller and motor must be at least 62.5% of the full load current. And for non-continuous duty motors, conductor ampacity should follow table 4.30.2.2e. Conductors for small motors should generally be no smaller than 2.mm, with exceptions as detailed in 4.30.2.2 G1 or G2. So this section details conditions for using 0.75 mm copper conductors. If the circuit supplies a motor with a full load current between 3.5 and 5 ampere, it must be protected per 4.30.4.2 have class 10 per 10 amperes overload protection and overcurrent protection per 2.40.1.4 D to B. For motors 3.5 amps or less, the circuit must be protected per 4.30.4.2. Also, this section covers the use of 1.25 mm copper conductors. For motors with a full load current between 5.5 and 8 amps, the circuit needs protection per 4.30.4.2. Class 10 per 10 amperes overload protection per 4.30.3.2 and overcurrent protection per 2.40.1.4 D. It also mentions class 20 overload protection in accordance with 4.30.3.2. And for motors with a full load current of 5.5 amps or less, circuits using 1.25 mm conductors must have protection per 4.30.4.2 and class 20 overload protection per 4.30 per 0.3.2 and overcurrent protection per 2.40.1.4 D2. And for wound rotor secondaries in continuous duty, conductors connecting the secondary to the controller need an ampacity of at least 125% of the full load secondary current. And the wound rotor motors, the ampacity of conductors between the controller and resistor should follow table 4.30.2.3c. Table 4.30.2.2e, it provides nameplate current rating percentage for duty cycle service. Note that any motor application is considered continuously duty unless it cannot operate continuously with a load. Conductors supplying several motors or other loads must have an capacity not less than the sum of specific requirements. 1. 125% of the full load current rating of the highest rated motor as determined by 4.30.1.6a. 2. Sum of the full load current ratings of all the other motors in the group as determined by 4.30.1.6a. Number 3. 100% of the non-continuous non-motor load. Number 4. 125% of the continuous non-motor load. So when supplying several motors and other loads, you must calculate the required conductor ampacity by summing 125% of the highest rated motor's full load current. The full load currents of all the other motors is 100% of the non-continuous non-motor load and 125% of the continuous non-motor load. And as you can see, table 4.32.2.3c, it details secondary conductor ampacity based on resistor duty classification. And when calculating conductor ampacity, consider these exceptions. For short-time duty motors, use the ampere rating from 4.30.2.2e or 1.25 times the continuous duty full load current. Whichever is greater, conductors for motor-operated space heating must comply with 4.24.1.3b. For interlocked circuits preventing simultaneous operation, base capacity on the highest total current from simultaneously operated loads. And for multi-motor equipment, use the minimum circuit ampacity marked on the equipment. And when using capacitors with motors, conductors must comply with 4.60.1.8 and 4.60.1.9. Feather tap conductors need an ampacity as per part 4.30.2 and it must terminate in a branch circuit protective device, also meeting one of these. Enclosure within 3000 mm with overcurrent protection, rating not exceeding 1000% of tap ampacity, and ampacity of at least 1/3 of feather conductors protected from damage within 7,500 mm, or ampacity not less than the feather conductors. To ensure qualified personnel service the systems, conductors tapped to a feeder can be up to 7,500 mm horizontally and 30 meters in total length if tap ampacity is at least 1/3 of the feeder. Tap conductors terminate with a circuit breaker or fuses complying with the ampacity requirement. The tap conductors are protected from damage and in raceways. And tap conductors are continuous with no splices. Conductors are at least 14 mm copper or 22 mm aluminum, and they don't penetrate walls, floors, or a ceiling. And also the top must be at least 9,000 mm from the floor. For constant voltage direct current motors, conductors connecting the controller to power resistors in the armature circuit should have an ampacity calculated from table 4.30.2.9 using the motor's full load current. Armature shunt resistor conductors also nagdiin siya og ampacity calculated from table 4.30.2.9 using the rated shunt resistor current. And for part 4.30.3, it specifies overload devices to protect motors and conductors from overheating due to overload and failure to start. These overload protection provisions don't apply where power loss would create a hazard, like with fire pumps. Also, Part 4.30.3 does not apply to motor circuits over 1000 volts. For continuous duty motors over 1 horsepower, overload protection is required via methods in 4.30.3.2a 1 through a4. A separate overload device must be responsive to motor current and rated at a specific percentage of the motor's nameplate full load current. And the overload device's rating depends on the motor type. 125% for motors with a service factor of 1.15 or higher, and 125% for motors with a temperature rise of 40 degrees Celsius or less, and 115% for all other motors. For multi-speed motors, treat each winding connection separately. Thermal protectors integrals with a motor must prevent dangerous overheating due to overload. As you can see, table 4.30.2.9 provides conductor rating factors for power resistors based on duty cycle. The ultimate trip current for thermally protected motors should not exceed percentage in table 4.30.14.2 to 4.30.14.4. And for motors with a full load current of 9 amps or less, the limit is 170%. For currents between 9.1 and 20 amps, it's 156%. For motor full load currents greater than 20 amps, the ultimate trip current is limited to 140%. If the current interrupting device is separate but controlled by a motor integral protective device, the control circuit's opening must interrupt current to the motor. Automatically started motors of 1 horsepower or less need overload protection via a separate overload device following requirements in 4.30.3.2a1. And for multi-speed motors, each winding is considered separately. Thermal protectors must prevent dangerous overheating. Integral protective devices are allowed if the motor is part of an approved assembly not subject to overloads, or if the assembly has safety controls. Impedance protected motors can be protected as per 4.30.3.2d2a if they are part of an assembly that prevents dangerous overheating. Many AC motors less than 1 to 20 horsepower, such as clock and series motors, fall under this classification. And if the standard overload device is not sufficient, larger elements can be used. but the trip current must not exceed this percentage. 140% for motors with a service factor of 1.15 or greater, and 140% for motors with a temperature rise of 40 degrees Celsius or less, and 130% for all other motors. Class 20 overload relay provides a longer motor acceleration time than Class 10 or 10 amperes relays. Class 30 provides even longer acceleration. For non-automatically started motors of 1 horsepower or less, permanently installed motors need overload protection in table 4.30.3.2b. If not permanently installed but within sight of the controller, protection can be from the branch circuit device and not exceeding 4.30.4. And wound rotor AC motor secondary circuits can be protected against overload by the motor overload device. Intermittent duty motors can be protected by the branch circuit device, provided its rating does not exceed table 4.30.4.2, and any motor application is considered continuous duty unless if cannot operate continuously with load. And also for non-automatically started motors, overload protection can be shunted during starting if it cannot be left in the starting position and if fuses or breakers are rated at no more than 400% of the full load current. And for the automatically started motors, overload protection cannot be shunted during starting. An exception exists if the starting period exceeds the available protective devices. Time delay and listed means are provided to sense motor rotation and prevent shunting if the motor fails to start. Limit shunting time to less than the locked motor time rating, and provide for shutdown or manual restart if a running condition is not reached. When using fuses for motor overload protection, place a fuse in each ungrounded conductor and also in the grounded conductor for 3-wire 3-phase AC systems with one conductor grounded. And for non-fuse overload devices, Table 4.30.3.7 dictates the number and location of overload units. Overload devices, excluding fuses or thermal protectors, should simultaneously open enough ungrounded conductors to stop the current flow. A motor controller can act as an overload device if it meets Table 4.30.3.7 requirements and is operative in both starting DC or running AC. Overload relays incapable of opening short circuits or ground faults must be protected by fuses or circuit breakers per 4.30.4.2 or a motor short circuit protector per 4.30.4.2. If approved for group installation and marked with a maximum fuse or breaker size, protection must follow that marking. And for motors on general purpose branch circuits, overload protection is detailed in 4.30.3.12a, B, and C, O, and D. Motors 1 horsepower or less without individual overload protection can connect to a general purpose circuit if it meets conditions in 4.30.3.2b and 4.30.3.2d and 4.30.4.3a1 and a2. Motors larger than 4.30.4.3a can connect to general purpose branch circuits if each motor has overload protection per 4.30.3.2. The controller and overload device must be approved for group installation with a short circuit or ground fault device per 4.30.4.3. And for cord or plug connected motors where overload protection is omitted per 4.30.3.12a. The plug or connector rating cannot exceed 15 amps at 125 to 250 volts. And as you can see, table 4.30.3.7, it details overload unit requirements. And the branch circuit protective device must have a time delay allowing the motor to start and accelerate. Automatic motor restarting after overload tripping is only allowed if approved for the motor and if it won't cause injury. If immediate shutdown poses a hazard, a motor overload sensing device can connect to a supervised alarm to initiate corrective action or an orderly shutdown. 4.30.4 Motor branch circuit, short circuit, and ground fault protection. Part 4.30.4 details devices protecting motor branch circuit against overcurrent from short circuits or ground faults. Adding to Article 2.40, these rules don't apply to circuits over 1000 volts. The protective device must comply with 4.30.4.2b and either C or D and must be capable of carrying the motor's starting current. C. Rating or setting. Protective device should have a rating per table 4.30.4.2 if the table 4.34.4.2 values don't match standard sizes. The next higher standard rating is allowed, and if the table 4.30.4.2 rating is insufficient for starting current, and non-time delay fuse with 600 ampere or a time delay class CC fuse can be increased, but not over 400% of the full load current. Time delay or dual element fuses can increase, but not over 225%. Inverse time circuit breakers can increase, but not over 400%. And for full load currents greater than 100 amps, the rating can be increased to a maximum of 300%. For fuses of 601 to 6000 ampere classification, the rating can be increased but not over 200% of the full load current. Maximum ratings in the manufacturer's overload relay table must not be exceeded. Instantaneous trip circuit breakers are only used if adjustable and part of a combination controller with coordinated overload and short circuit protection. It is set per table 4.30.4.2. So kaning slide nag-discuss siya sa exceptions for instantaneous trip circuit breakers. Kung ang setting sa table dili sapat for starting current, pwede i-increase ang setting, but dili mo lapas sa 1,300% or 1,700%, depende sa motor type. And also, if the motor full load current is 8 amperes or less, the breaker setting can be increased to the value marked on the controller. And also, nag-discuss po ni siya sa motor protection. For multi-speed motors, a single protective device is allowed for multiple windings basta ang rating dili mula pa sa percentage sa nameplate. Na exception kung ang conditions A, B, and C are met, like individual overload protection and proper conductor sizing. Also, semiconductor fuses are okay for power electronic device or devices. Number 6 is this, nag-discuss niya sa self-protected combination controllers. This can be used instead of devices in table 4.30.4.2 nga ang adjustable instantaneous trip settings dili dapat molapas sa 1,300% or 1,700% depending sa motor efficiency. And also, motor short circuit protectors are allowed if part of a listed combination. And next is, nag-present siya sa table 4.30.4.2 and nag-show siya sa maximum ratings for motor branch circuits. It lists percentage for fuses and breakers based on motor type. Remember, ang motor controller nag-provide og overload and short circuit protection. Also, motor short circuit protector is a fuse device, dili instantaneous trip breaker. And also, this slide covers motor branch circuits. Torque motors need protection based on their nameplate. Daghang motors or loads can share a circuit under specific conditions. Next slide discusses individual overload protection and group installations. If the branch circuit protection does not exceed what's allowed for the smallest motor, multiple motors with individual overload protection can be on one circuit. For other group installations, two or more motors can be connected to one branch circuit kung naay individual overload protection and specific conditions are magtagbo, like factory assemblies or field installed components. Next, it details requirements for motor overload devices and controllers in group installations. Each overload device and controller must be listed for group use or selected based on 4.30.4.2. Ang circuit breakers dapat inverse time type. The branch circuit protection should be fuses or inverse time breakers, calculated based on the highest rated motor plus the sum of other loads. If the calculation is less than the conductor capacity, pwede nimo i-increase ang fuse or breaker rating. This slide continues group installation rules. Branch circuit fuses or breakers can't be larger than allowed for the smallest motor overload relay. Overcurrent protection for non-motor loads follows parts 2.40.1 to 2.40.7. And for single motor taps, conductors supplying a single motor don't need individual protection basta i-meet nilang certain ampacity requirements like being equal to the branch circuit conductors or at least at least 1/3 with proper protection. Sunod, details top conductor requirements for group installation. Conductors from the top to a listed manual motor controller can have an ampacity of 1/10 the branch circuit protection rating. Basta ang conductors gikan sa controller padulong sa motor, nag-follow na siya sa table 4.30.2.2. And also, the top conductors must be protected and enclosed, either by an enclosed controller or a raceway, and have length limits. And conductors from the top to a listed manual motor controller can have an ampacity of 1/3 that of the branch circuit conductors. So as you can see, it covers various protection requirements. For multi-motor equipment, the branch circuit protection rating cannot exceed what's marked on the equipment. Combined overcurrent protection is allowed if it provides the necessary overload protection. And also, fuse holders must be sized appropriately for the fuses used according to table 4.30.4.2. Pero kung time delay fuses ra ang imong gamiton, pwede ang fuse holders na size to fit those fuses. nag-cover na po ni siya sa motor feeder protection. Part 4.30.5 protects feeders against overcurrents from the short circuits or grounds. For a specific motor load, ang feeder protective device rating should not be greater than the largest branch circuit protection rating plus the sum of the full load currents of other motor in the group. So next slide, it covers control circuit protection. Overcurrent protection can be omitted if opening the circuit creates a hazard, like with fire pump motors. Kung ang transformer nag-supply o class 1, 2, or 3 circuit, protection must comply with Article 7.25. Transformers less than 50 VA within the motor controller can be protected by primary overcurrent devices or impedance limiting means. So this slide covers motor circuit requirements. If the primary current is less than 2 amperes, the overcurrent device can be rated at 500%. And the conductors must be protected from physical damage. Kung ang control circuit grounded, ground fault should not start the motor or bypass shutdown devices. Control circuits must disconnect from all sources when the disconnecting means is open. And also, this slide details exceptions for control circuit disconnects. If more than 12 conductors need disconnecting, the disconnect does not have to be immediately adjacent if access is limited to qualified personnel and warning signs are present. The disconnect can also be remote if opening it could create unsafe condition. Basta same ra sila og conditions about access and warning signs ang magkita. Next is the last slide presents table 4.30.6.2b showing maximum overcurrent protection ratings for control circuit conductors. Kung ang control transformer na sa controller enclosure, dapat connected ni sa load side sa disconnecting means para sa motor control circuit. This ensures the transformer is de-energized when the disconnecting means is open. So, thank you for listening. I hope you learned something about the PEC from my report. Thanks again, and don't forget to like and subscribe to my YouTube channel for more videos.